Let's learn real analysis on TikTok part 6. Today we're going to see a full proof. Let's think about this set S up here. So we take all the natural numbers, 1, 2, 3, etc. and we form this fraction and we subtract it from 2. Now all of these numbers are going to lie to the left of 2, but if n is astronomical, like 1,000,000 or 1,000,000,000, the idea is these are getting closer and closer to 2. And so the least upper bound, that's what sup means, the supremum, is going to actually be 2. Now that's a great intuitive reason for why this is true, but in analysis we have to prove everything and we have to be rigorous about it. So we did lots of these examples in class today, but we talked about to prove something is the least upper bound, there are 2 steps. First, we have to show it's an upper bound. In other words, 2 is bigger than every element in the set. In this case, this is clear because we have the number 2 and we're subtracting a positive amount to get a given element of our set. And then the step that's a lot more complicated. And so we have to show that no number smaller than 2 could possibly be an upper bound. Because who knows, maybe 1.999999, maybe that number is bigger than everything in our set. So we argue by contradiction. We take this red number m and we say, well, suppose there was something smaller than 2 that, could be an upper bound. We're going to have to rule that out. And so I take a number less than 2 and I claim that it's not going to be an upper bound. And then I write a famous mathematician word indeed, which means I'm going to explain why. So I'm going to use this number d, which is just the distance between m and 2. It's probably a really small number, who knows. And what I'm going to do is I'm going to find a whole number, a natural number, so that when I do 1 over that number, it's smaller than d. Now I can do that by the Archimedean principle that we talked about in day 5. And so what I have is the blue 1 over n is definitely smaller than d. And if you look at the inequalities down below, and I can move myself, so let's do it, 1 over 3n plus 1, that same capital N, is going to be a smaller number than 1 over n, and we know that's less than d, and hey, that was equal to 2 minus m. Doing a little bit of algebra, moving that m from the right-hand side to the left and moving that 3m plus 1 to the right, I see that m is actually smaller than that thing on the right, which is an element of S, because it's of the form that we started with. So this does show that our number m is not an upper bound for our set. We found an element of S that was bigger than it. So that's a full proof showing that the number 2 is the least upper bound for that particular set. You may have noticed there were lots of little intricacies we had to work through in the proof, and believe me, things can get way more technical. If that had been instead of a 3n plus 1, but there had been minus signs kind of mixed in, or worse, what if it was a quadratic in the denominator or a cubic? These proofs could get pretty messy because you have to be careful when you're dealing with negative numbers and inequalities. Now there are ways to fix a lot of this, and so as we move through the course, we'll develop lots and lots of tools to ultimately help make these problems a lot easier. But then proving those tools is also a lot of work. So stay tuned for the next day. We're going to talk about how the rational numbers are dense, what that means, and I'll show some pictures of cookies.